Here we are again. This is Algebra 2, first semester, Chapter 3, Section 2 from the Big Ideas Math. And we are learning about solving quadratics. And today our essential question is, what is a complex number and how is it used? So before we get to that, let's just go over what we know about square roots. And you're probably going to remember this from Algebra 1, and if you do, that's awesome. And if you don't worry, we're going to get some practice right now. So first of all, the square root of 9, well, what is the same number times itself, so this number times itself, that makes 9? And it's just 3. How about the square root of 0? Do you remember square root of 0? 0. Now, C is a little bit tricky because it says negative square root of 4. So you know the answer is going to have a negative out front, and the square root of 4 is 2. So wow, that was really scribbly, but you should have negative 2. How about square root of 4 over 9? Just 2 over 3. Square root of 2? I don't actually know what the square root of 2 is. So I'm going to leave it as the square root of 2. That's one we don't have memorized. It's an irrational number. It's a decimal number that's never going to stop, kind of like pi. So look at letter F, you've got negative 1. Now, in the past we would say that there was no real solution or that it was not real. But today we are going to learn something new about that. Alright, so let's learn it. It says the square root of a negative number. What you do is you put an I out in front because it's imaginary. It's an imaginary number. So we learned that I squared is negative 1, and we learned that the square root of negative 1 is I. And that is what this core concept bubble is trying to teach us, but I find it's easier when we just write it out like this. So let's write it like this instead. I squared is negative 1, and the square root of negative 1 is I. Alright, keep that in your mind, get that written in your notes, and let's try this. It says work with a partner. Please pause me. Work with a partner if you like. Use the definition of imaginary unit I to match each quadratic equation with its complex solution. Justify your answers. Okay, we're just going to talk about it. Look at letter A here. If I add the 4 to the other side, I'm going to get x squared equals 4. And when I square root both sides, I just get x is equal to plus or minus 2. So our answer then would be F, capital F. Tricky the way we're using capitals and lowercase. Okay, now over here, if I subtract the 1, I get x squared equals negative 1. And when I square root both sides, I get the square root of negative 1. And what did we talk about the square root of negative 1 being? Just being I, right? So I get plus or minus I. So lowercase b is capital A. Over here, x squared equals positive 1. When you square root both sides, you get x equals plus or minus 1. So you're looking at E. On letter D, x squared is negative 4. Square root that, and you get the square root of negative 4, which is the same as saying the square root of negative 1 times the square root of 4. And that is why the answer is 2i. Technically plus or minus, but we're going to keep the positive here. Alright, x squared equals 9. Square root both sides, you get plus or minus 3. That's letter C. And over here, x squared equals negative 9 is going to be plus or minus 3i, which was capital B. All right, let's move on. Find the square root of each number. So remember, technically, this is the square root of negative 1 times the square root of 25. We know the square root of 25 is 5, and we know the square root of negative 1 is I, so we write 5i. The 5 comes first because the real part comes first. Just the same way when we're dealing with variables like x, we would write 5x. We never write x5, so we're not going to write I5. Now, square root of 72 is going to be a little trickier for us. So we know it's the negative 1 here and a 72. We need to break down the 72. So in your head, you're thinking, what multiplies to make 72? Immediately, what comes to mind is a 9 and an 8, right? So let's go ahead and just do that. Here's 9 is a 3 and a 3. 8 is a 4 and a 2. And 4 is a 2 and a 2. That is an I, remember. So the 3 and the 2 go to break out of jail, and they become 6 because they multiply. The I also got to break out of jail, and we have the 2 left over. Now, let's do this a different way. The square root of 72 could be a 36 and a 2, and a 36 is a 6 and a 6, and we get 6 rad I, or 6 square root, sorry, I said I, 6 square root 2, or 6 rad 2, radical 2. And it was a little bit faster way of getting there, but if you don't recognize 36 coming from that 72 immediately, then a 9 and an 8 is a great way to do it. And of course, I left the I out because I was just showing you the square root of 72 here. All right, on letter C, we have a number, the negative 5, out front, multiplying the square root of negative 9. So it's the square root, sorry, it's negative 5 times the square root of negative 1 times the square root of 9. So far I have negative 5i, square root of 9, and the square root of 9 I know is a 3, so I have negative 15i. Excuse me. Alright, find the square root of again. Okay, press pause because I'm about to put the answers on. So I have 2i, 2i radical 3, negative 6i, and 6i radical 6, is it? I'm doing them in my head real fast, so let's just check that. I had the 54 and I broke it down with a 9 and a 6. 9 was 3 and a 3. I multiplied the 3 to the 2. There we go, 6i rad 6. Not bad for in my head at 10 o'clock at night, is it? Alright, let's keep going here. It says find the values of x and y that satisfy the equation 2x minus 7i equals 10 plus yi. Alright, here's the deal. You've got the real part and the imaginary part. Remember a plus bi, where a is the real part and bi is the imaginary part? Imaginary. Okay, so what that means is we need to equal the real parts and the imaginary parts to each other. So 2x is going to be equal to 10, and negative 7i is going to be equal to yi. So divide by 2, and x is 5. and we're solving for y here. So divide by I, and y is negative 7. So set the real parts equal to the real parts, set the imaginary parts equal to the imaginary parts, and you're done. All right, try that again. Press pause. So x equals 9, and 3i equals negative yi. Divide by negative I, and you get y equals negative 3. Over here, 9 equals negative 2x. Divide by negative 2, and you get x equals negative 9 halves. 4yi equals 3i. Divide by 4i, divide by 4i, and you get y equals 3/4. That was sloppy, I know, I'm sorry. I'll try to write slower. Okay, core concepts. I think the way they explain this maybe is a little overwhelming. So pretty much all you're going to do is add, subtract, and then combine like terms. So follow the examples and maybe it'll make more sense than my trying to explain this core concept to you, because you've done this before. We're just going to pretend the I is a variable like an x, and we're not going to have a problem. So I'm going to use my colors though. If you want to use colors, grab your colored pencils for your notes. There's an 8 and a 5. That's the real part with the plus sign between it. So I have 8 plus 5. And, okay, here come my colors again. I have negative I plus 4i. So 8 plus 5 is 13, and negative I plus 4i is 3i, and it's positive. And standard form, remember, is a plus bi. So I have 13 plus 3i. Okay, letter B, let's do this again. Look at the problem. 7 minus 6i minus the quantity 3 minus 6i. So I have 7 is a real part, 3 is a real part with a minus sign. So I have 7 minus 3, and I have negative 6 minus negative 6. Negative 6i minus negative 6i. Since it's a double negative, a minus minus, I'll put it in parentheses just for fun. Okay, so going back to black, 7 minus 3 is just 4, and minus minus makes a plus here. So negative 6i plus 6i is nothing, so it's plus 0, so I'm done. My answer is 4. Okay, on 13, it's a little bit different. I'm going to go ahead and just distribute this negative first, and then I'll combine like terms after that. So 13 minus 2 minus 7i, the plus 5i stays the way it is because it's not a part of the parentheses. All right, now let's go with the parts we have. We have a real part and a real part, so that's 11. And an imaginary part and an imaginary part is negative 2i. So I should have 11 minus 2i. And that is in standard form. A plus bi, 11 minus 2i. Perfect. Okay, it says multiply. Write the answer in standard form. Now remember, we've been dealing with these i's just like they're the variable x as far as these operations of addition and subtraction go. And we are still going to deal with this as if it were a variable for when we're multiplying. However, we have to remember that I squared is negative 1. That is going to come into play, so keep that in mind. I'm going to see if I can get a better pen thickness. Here we go. Distribute. So I have negative 24i plus 4i squared. Negative 24i plus 4 times what? What is I squared? I squared is negative 1. So negative 24i minus 4. Now I need to write my answer in standard form. Standard form is a plus bi. So I'm just going to write the negative 4 out front and the minus 24i or the negative 24i after. Done. Over here I have to FOIL. Those of you still trying to remember FOIL from Algebra 1, you can write it out if you need to. First, outer, inner, last. So the first is the 9 times the negative 4. Those are both in the first spots in the parentheses. That's negative 36. Outer is 9 times 7i. So that's positive 63i. Inner is negative 2i times negative 4, which is a positive 8i. And last is negative 2i plus 7i, so that's negative 14i squared. Okay, we have two things we have to do here. We have to combine like terms for our i's, and we have to substitute the negative 1 in for I squared. So I have negative 36. What's 63 plus 8? Tell me you got 71i, and then it's negative 14 times, and what is I squared? Negative 1. Okay, so that's negative 36 plus 71i plus 15. So you have negative 36 plus 15. That's negative 21. Bad guys won that one. Plus 71i. And that is in the standard form of a plus bi, so we're done. Okay, lots of problems here. It says perform the operation, write it in standard form. I'm just going to do all of them right quick, so please pause the video and grab a partner if you need to and work on these. Alright, so I've got my real parts. 9 plus negative 6, so that's a 3. Oops, looks like I lost my pen here. Alright, well I'll just keep talking and we'll see if I get my pen back. So 9 plus negative 6 is 3, and negative I plus 7i is 6i. So I should have 3 plus 6i. Okay, I didn't get my pen back, but I'll just keep talking. We'll see. 3 minus 8 is negative 5, and 7i minus negative 2i is actually 9i. Alright, I officially do not have a pen, but I guess I'll keep talking. 10 is negative 4 minus, okay, so I need to distribute this negative 1. Gonna wish I could write it down, huh? So it's negative 4 minus 1 minus 5. So negative 4 minus 1 is negative 5, and negative 5 minus 5 is negative 10. And then this is going to be negative I minus 9i, so it's minus 10i. So you should have negative 10 minus 10i. And I still don't have a pen, so I'm going to go ahead and stop the video, and I'll make a second video for this lesson.